Dear students, let me welcome you all to today's session. Today we are going to discuss a few good questions from this topic, that is permutations and combinations. And before we are starting with solving the questions, let us quickly go through some of the basic concepts that you should be familiar with so that you can attempt these questions in a very effective way. Okay, so the first thing that you all should remember and recall, it's that permutations. Okay, permutation, if I say, or permutations, if I say, please be aware that it is all about arrangements, arranging things, arrangements. Okay, arranging people. Okay, or arranging some given number of things, arranging some letters or arranging some vowels or consonants and all. Permutation, it's all about arrangements and combinations. Okay, when I say combination, please be aware that it is all about selection. Okay, so this is the first and most important thing that you should keep in mind. Permutation, it's all about arrangement. Combination, it is all about selection. Okay, now the next thing that you should keep in mind, something called as fundamental principle of counting, FPC, I will say, fundamental principle of counting. Fundamental principle of counting, two things are there. Fundamental principle of counting, the first one, it's addition. Fundamental principle of counting, the next one, it is multiplication. Okay, what it is all about, let us quickly go through it. Consider that there is a task 1. One task is the task 1. Let me say you can finish doing task 1 in m ways. Okay, there is another task, task number 2. Let me say you can complete the task number 2 in n number of ways. Okay, now suppose somebody asks me, in how many ways you can do task 1 or task 2. Listen carefully. Somebody asks you, in how many ways you can do task 1 or task 2. Your answer, it will be m plus n. Okay, please be aware of this. When I use the logic or, it will be addition. Please be aware of this. Somebody asks you, in how many ways I can do task number 1 and task number 2. Then the answer, it will be m into n. You have to go ahead with multiplication in that case. The number of ways you can do task 1 and task 2, it will be m into n. So solving questions based on permutations and combinations, you should know when to use permutation. That's the case when you are dealing with arrangements. When to use combination, that's the case when you are dealing with selection. And then comes the fundamental principle of counting. There we have addition and multiplication. So please be aware, when the logic you are dealing with, it is or, it's all about addition. The logic that you are dealing with, if it is and, please be aware, it's all about multiplication. Okay. So with this quick note, we will start with our questions. So I shall present the first question in front of you. So you can just go through this first question. Okay. So here we go. The first question is in front of you. How many words it can be formed using all the letters of this word question without repetition so that the vowels occupy the even places? That's the question. So, when I am observing this word question, okay, I can see that Question. Altogether, there are 8 letters. Okay. Now, please observe closely. In these or among these 8 letters, I can see that U is a vowel, E is a vowel, I is a vowel, O is another vowel. Right? So, there are altogether 4 vowels. And we can see that there are altogether the remaining 4 consonants. Right? So, I have understood that question, this word is 8, it is having 8 letters. There are 4 vowels and there are 4 consonants. Now, let me go ahead with 1, 2, 3, 4, 5, 6, 7, 8. These are the positions. 1, 2, 3, 4, 5, 6, 7, 8. Please be aware, in the question it is said, in how many words can be formed using all these letters without repetition so that the vowels occupy the even places, which means the U, the E, the I and the O, the 4 vowels, they should be occupying the even places, which means 2, 4, 6, 8. Let us deal with that constraint first. Okay, so here the first vowel should come, the second vowel should come, the third vowel should come, the fourth vowel should come, right? Now, in the same way, there are 4 consonants. Automatically, the 4 consonants will be occupying the odd positions. The consonant 1 will be in the first position. Consonant 2 will be in the third position. Consonant 3 in the fifth position. And consonant number 4, it is going to be in the 7th position. Automatically, it comes that way. Okay. So, how many ways these 4 vowels can be arranged in these 4 positions? You can see that these 4 vowels can be arranged altogether in 4 factorial ways. Okay. And we can see that these 4 consonants, they can also be arranged in 4 factorial ways. Got it? So, we can thus see that the 4 vowels can be arranged in 4 factorial ways. The 4 consonants can be arranged in 4 factorial ways. The letters are arranged only when you take care of vowels and the consonants. Please be clear with this point. Only when you take care of the vowels and the consonants. Right? So, I am writing it here. You have to take care of the vowels and its consonants. Okay? So, your answer, it will be 4 factorial into 4 factorial. You know that 4 factorial, it is 24. You are multiplying 24 into 24. You can see that 24 into 24, the result, it is 576. So, for this particular question, my final answer, it will be equal to 576. Okay? I hope the first question and its related explanations are clear to you. So, make a note of these steps. Let's proceed with the second question. All right. So, I'll present the question in front of you. I gave an easy question for you to start with. As we are proceeding, I shall give you more and more tricky questions. Okay. So, let's go ahead with the second question. So, here we go. Question number 2. It is asked, in how many ways can the letters of this word heptagon be permuted so that the vowels are never separated? It means that in this word heptagon, the vowels are always together. Okay. So let us consider this word heptagon, H-E-P-T-A-G-O-N. A, G, O, N. We can see that the vowels are E, A, and then this O. H, P, T, G, N. None of the letters are repeating. There are 3 vowels. Okay, so I am now taking H, P, T, G, N separately, and I am bundling this E, A, O, the 3 vowels together as a single unit. Okay, so when I am observing here, I can see that I need to take care of arranging EAO as a single unit and then HPTGN as individual units. So altogether I have got 1, 2, 3, 4, 5, 6 units to take care. Okay, so these 6 units, HPTGN, EAO as a single unit, the 6 units, I can arrange them all together in 6 factorial ways, right? And how about EAO? EAO, even though it is a single unit, between themselves, EAO, they can be arranged in 3 factorial ways. So altogether, the number of ways I can do it, it will be taking care of the individual units separately and taking care of these 3 separately. Okay, so I can see that taking care of all these 6 I meant 1, 2, 3, 4, 5, 6, all these 6 separately and taking care of that EAO within themselves separately. So task 1 can be completed in 6 factorial ways. Task 2 can be completed in 3 factorial ways. Task 1 and task 2 taking care between themselves and within themselves. I want you to make a note of these 2 cases, between and within. Okay, so make a note of these 2. I am considering that logic and here, that is why it is coming as 6 factorial into 3 factorial. My final result, it will be 4320 it will come. And for this particular question, option D, it reads 4320 and that is my final answer. All right. Let's now go ahead with the next question. Let me load the question for you. So here we go. It's all about quickly revising what is about permutation when repetitions of letters are happening. Okay. In how many ways can the letters of the word combination be permuted? That is the question. So when I am looking at this word combination, I can see that COMBINATION. I can see that there are altogether 11 letters, right? There are 11 letters. And in this, I can clearly see that this letter O, it is happening twice. You can see that O is present here, that O is present here. It is present twice. Okay. In the same way, I can clearly see that this letter I, it also repeats 2 times. So I, you can say it happens twice. Okay, 2 times. Okay, so I'm just writing it here. I, it also comes here 2 times. Okay, and in the same way, we can see that this letter N, you can see that it appears here, it appears here. You can see that N also, it happens 2 times. Cool. None of the other letters remaining, C, M, B, A, T. Okay. We can see that none of them are repeating or they are coming exactly once. So let's not bother about them. So here, when the letters are getting repeated, you are aware that the total number of ways in which these letters, they can be permuted, arranged among themselves. It will be 11 factorial. You have to take care of the total number of letters associated with that word, 11 factorial in this case, divided by whatever that is repeating. This 2 factorial, it is for the two O's that are coming. This 2 factorial, it is for those two I, the letter I that is coming. And this 2 factorial, it is for those two N that are coming. So we can say altogether, my final answer, it will be 11 factorial upon 2 factorial into 2 factorial into 2 factorial. If you are looking at the answer choices, I can see answer choice here, B, it reads 11 factorial by 2 factorial to 2 factorial to 1. That is going to be my choice. Option B, it's my final answer. Okay. Let's now consider the next question. I'm taking care of question number 4 now. It's a very interesting question, this one. It's about forming some numbers as such. So take a look at this question. Take your time to read and understand the question, and then I shall go ahead with giving you the explanations. Okay. And I shall add one more point to this question. Okay, one more question. Continuation is there. That also I shall present it here. So this is what it is. Okay, two questions back to back. So same, it's continuation only. Okay, this is the first part and this is the second part. So let's have a look at this question. How many 4-digit numbers having distinct digits can be formed using the digits 0 to 9? Okay. So we are dealing with, I'm attempting the first part of the question, part 1, I am attempting. Okay. So we are dealing with 4-digit number, right? So I can clearly see that it is given 4-digit numbers having distinct digits, which means I cannot repeat the digit which is already used. And you are considering all the digits from 0 to 9. 0 to 9, when you take 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits are there. So let me consider the number of ways I can take care of the leftmost position, the thousandth digit I'm considering. The number of ways I can take care of the leftmost digit, you know, I can take care of it in 9 ways. Okay, I can fill it with either 9 or 8 or 7 or 6 or 5 or 4 or 3 or 2 or 1. I cannot use 0 in the leftmost position. 0 I cannot use in the leftmost position. If I do that, then it will become either a 3-digit number or a 2-digit number and all. I can't use 0. Okay, so the number of ways I can take care of the leftmost position, it is 9 ways. Okay, so 9 ways I can take care of the thousandth digit position. So 1 digit is gone. I don't know which digit is that, but 1 digit from 0 to 9, when you are considering altogether, there are 10 digits are there. Okay, 0 to 9, 10 digits are there. Out of that, 1 digit is gone. Now you are left with dealing with 9 digits. Okay. So there, when you consider the number of ways you can take care of the, say, the hundreds position, if I consider, I can again do that in 9 ways. You know why 9 ways? Because 1 digit is used, but 0 is now coming in. So 0 is coming back. The digit which I have already used, I cannot use it again because they have mentioned that it are distinct digits. So 9 ways I can take care of the hundreds position. And I can see that I can take care of the tens position in 8 ways. And I can take care of the units position in 7 ways. Because as I am traveling from left to right, I am using one digit each. So the number actually comes down. Please be aware here it is 9 because I have already used up 1 digit that I can't use it again, but 0 comes in. So effectively, I'm having 9 ways I can deal with the hundreds position. 8 ways I can deal with the tens position because 2 digits I have used up here out of 10. 2 gone means remaining is 10. Sorry, 2 gone means the remaining it is 8. So 8 ways I can take care of the tens position. I have used 3 digits from 10 when 3 goes off, 7 remaining. 7 ways I can take care of our units position. So the number of ways altogether I can deal with these positions are 9, 9, 8, 7. The number is formed only when you take care of the thousands position and the hundreds position and the tens position and the units position. So my answer will be 9 into 9 into 8 into 7. Okay. So we can see that here, when you do this calculation, 9 into 9 into 8 into 7, I can see the result, it is 4,536. 4536 comes, and the answer is option D in this case. Okay. So that is for the first part. The second part, it is tricky. They are telling you in this, how many of the numbers are divisible by 5? Okay. So there we are considering for the part 2, I am saying 2 cases are there. Okay. Whenever you get a question of this type, please be aware. Part 2, when you are considering, this itself has got 2 possibilities. What are they? Case 1, that is when the number is ending in 0. The number, it ends with 0. Okay. It ends with 0. Then I can consider that the number is divisible by 5. Okay. So I can thus see that out of 10 digits, I have used up 1 digit. That is 0. So 1 gone, which means 9 ways I can take care of the thousands position. So I have used up 2 digits. 8 ways I can take care of the hundreds position. And 7 ways, I can take care of the tens position. So the number that ends with 0 when you are considering 9 into 8 into 7, this many ways I can consider. 9 into 8 into 7, you can see that it comes as 504. Okay, so of those digits, of the numbers what I considered, there are 504 numbers that are actually ending in 0. That ends with 0. The number of ways it is 504. Or there is another possibility. You know what it is? It is ending with 5 because divisibility by 5 means the units digit, it should end with 0 or it should end with 5. So I'm considering the second case, it is ending with 5. So I'm writing it here. It ends with 5. Okay. So now you can see that here I have used up 5, the digit. Out of 10 digits, 5, that digit is gone. 0 cannot be used in the thousands position. You got my point? So 5 you cannot use again. 0 you cannot use again. So out of 10, 2 digits gone. You can see that 8 remains. So the number of ways I can take care of the thousands position, it is 8. 8 ways I can take care of the thousands position. Now, when I move from the thousands position to the hundreds position, you are aware that I have used up 5. I have used up another digit other than 0. So 2 digits are gone. So I can take care of the hundreds position in 8 ways. So I have used up 3 digits now. So remaining 7 digits, I can take care of the tens position in 7 ways. So that ends with 5. The number of ways it happens will be when I take care of the thousands position and the hundreds position and the tens position. So it will be 8 into 8 into 7. I can see 8 into 8 into 7 will come as 448. So that ends in 5. 448 ways are there. Altogether, when I am dealing with all those numbers that are divisible by 5, there are 2 cases, as I said. it ends with 0 or it ends with 5. And this is the case, a classical case where you can see both the fundamental principle of counting, they come to picture. So you can see that here it is and the thousands and the hundreds and the tens and the units. That's why I multiplied. I got it as 504. Here also it is 8 into 8 into 7. I can see that it is ending in 5. 8 into 8 into 7, 448. But altogether, when you see this, you can see that it can end with 0 or it can end with 5. Task 1 can be completed in 504 ways. Task 2 can be completed in 448 ways. Task 1 or task 2 altogether, you can complete it in 504 plus 448. All put together, I can see the value will come as 952. And for this question, option D, it reads 952. That is going to be my final answer here. Okay. So make a note of all these steps and be aware of the fundamental principle of counting. Accordingly, take care of the questions. Okay. Let's now move to the next question. We have completed so far 5 odd questions in this discussion. Let's now move to the next question. Take a look at this question. How many 4-digit numbers that are divisible by 3 can be formed using the digits 0, 2, 3, 5, 8 if no digit occurs more than once in the number? So the first thing that you have to understand is what is the condition for a number to be divisible by 3? For a number to be divisible by 3, you are aware that sum of all the involved digits, when you take it, it should be a multiple of 3. Got it? Sum of all the digits that are involved in that number, the 4-digit number, when you are adding them, that total, it should be a number which is a multiple of 3. Okay, so first let me add 8 plus 5, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the total is coming as 18. Okay, so 2, 3, 5, 8. That is one particular combo you can think of. 2, 3, 5, 8. Okay. So in how many different ways you can arrange that 2, 3, 5, 8? Those 4 digits you can think of, because whichever way you are going to arrange them, the total will be 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. The total will come as 18 only. You got it. So those numbers that you form, say 2, 3, 5, 8, 2, 3, 8, 5, 2, 5, 3, 8, 2, 5, 8, 3, all those things, they all will be pakka divisible by 3. So I got one set here to be arranged 2, 3, 5, 8. Now, let us consider the total, it should be multiple of 3. So if at all I am going to remove one digit from 0, 2, 3, 5, 8, that is possible only when you remove or when you kick out that digit 3, which means you end up considering 0, 2, 5, 8. You add these digits 8, 9, 10, 11, 12, 13, 14, 15, and this 0 comes here. Okay. Now, if you try to form numbers like 0, you remove 2, you have 3, 5, 8. Or you consider something like you remove 5. So you have 2, 3, 8. 0, you remove 8 so that you have 2, 3, 5. Okay, whichever the remaining that you are considering. Okay, in the first case, I have removed 0. In the second case, I removed 3. In this case, I have removed 2. In this case, I have removed 5. And in this case, I have removed 8. Okay, so now I am forming that 4-digit number, as you can see. But instead of these two, if I am going to consider these 3, I can say 8, 9, 10, 11, 12, 13, 14, 15, 16. The total is 16. The number will not be divisible by 3. 8, 9, 10, 11, 12, 13. You can see the total is 30. Then the number that you are, or numbers that you are going to form with 0, 2, 3, 8, none of them will be divisible by 3. And same will be the case here. None of them will be divisible by 3. Okay, the numbers that you form. So these three you need not consider. So we can see that you are left with two cases here, 2, 3, 5, 8 case, or you are considering the 0, 2, 5, 8 case. 2, 3, 5, 8 when you consider, you are forming 4 digits, no? So they can be within themselves arranged in 4 factorial ways, and you know that is equal to 24. 2, 3, 5, 8, 2, 3, 8, 5, 2, 8, 5, 3, 2, 8, 3, 5, whatever be. Okay, 4 factorial 24. As far as the second one it is concerned, please be aware, you have got something like 0, 2, 5, 8. How many ways you can arrange these 4? That is the question. So definitely you cannot start with 0 because you are dealing with 4-digit number. You cannot start with 0. So the thousands portion may be filled with 2 or with a 5 or with an 8. So you can take care of this position in 3 ways. Got it? Let me say I used 8. Let me say. Okay. Then I am left with 3 digits here, which can be, one of these 3 digits can be used in the hundreds place. So the hundreds position can be filled in 3 ways. Got it? And you can see that suppose I use the digit 0, the tens position, you know, you can fill it in 2 ways. You either with a 2 or with a 5 maybe. Okay. And suppose I use 2, you can see that the units position, only 5 is remaining. I can fill it in 1 way. So you can see the number of ways I can form a 3-digit, number of ways I can form a number which is divisible by 3, you know, it is 3 into 3, 9, 9 2s are 18. I can see this can happen altogether in 18 ways. Got it? So please be aware of this. Case 1, I kicked out 0, 24 ways are there. In the second case, I kicked out 3, 18 ways are there, 18 numbers are possible. All other instances, if I kick out 2 or 5 or 8, the number that so formed will not be divisible by 3. So I need not consider those 3. So the total number of ways I can get this thing done is 24 plus 18. Why I am doing plus here? It is either this way or this way. So it is 24 plus 18 that actually comes. And I can say my answer, it is equal to 42. So for this particular question, my final answer for the 6th question, it will be equal to 42. Got it? So that brings conclusion to this question here. Let us now go ahead with our next question, which is lined up for the day. Please take a look at this question. Here we go. How many even numbers between 20,000 and 40,000, excluding the extremes, can be formed using the digits 0, 2, 3, 4, 6, 8? If any digit can occur any number of times, which means repetition is permitted. Okay, so that's the question. So take a look at this question and then let us consider. So how many even numbers? So that's a big constraint there. They are talking about even numbers. It is between 20,000 and 40,000. Excluding the extremes they have told you, that can be formed using the digit 0, 2, 3, 4, 6, 8. If any digit can occur any number of times. Okay, so let me consider we are dealing with all 5-digit numbers here. Do you agree with me? That's the first thing that you have to understand. 1, 2, 3, 4, 5. All those digits, you know, 5-digit numbers, right? Now, we can consider the number of ways you can take care of the units position. They have given the condition that the so formed number, it should be even. Even means what? The units place, please be aware, units place, it should end with 0, 2, 4, 6, 8. With any of these 0, 2, 4, 6, 8. You can see that as far as the given set is concerned, 0, 2, 4, 6, 8. All these digits are available. ये सब digits मौजूद है यहाँ, right? 0, 2, 4, 6, 8. So the units position, please be aware, you can fill it in 5 ways. Got it? So that is taken care. Now, let us now focus on the leftmost position, the 10,000s position. I cannot fill it with 2. Okay. And also, I cannot fill it with 4 because excluding the extremes they have told you. So 2 is gone, 4 is gone. Please be aware, the leftmost position, I cannot fill it with 0 either. So the leftmost position, 0 is out, 2 is out. Wait a second. Is 2 possible? 2 is possible, right? 20,000 is what they have told you. So 0 is not possible. And please be aware, 4 is not possible. My mistake. 0 is not possible. 4 is not possible because definitely leftmost cannot be 0. Even if I am going ahead with 4, it is going to be 40,000. That is what you are going to deal with. 40,000 I can't take. So I am now left with how many choices there? I can fill the leftmost position either with 2 or with which one? Can I fill with here when I'm observing leftmost position? Let me just think once again. I can fill it with 2. Okay. I have missed out 3 there. Okay. Units place, what I have said here is 0, 2, 3, 4, 6, 8. Okay. So I cannot fill it with 0. I cannot fill it with 4. I cannot fill it with 6. I cannot fill it with 8. I can fill it with 2 or I can fill it with 3. Okay, so the number of ways I can take care of the 10,000s position is in 2 ways, right? Now, let us consider the number of ways I can take care of the thousands position. Thousands position, no condition. 1, 2, 3, 4, 5, 6. All 6 digits are possible because repetition is permitted. So 6 ways I can take care of the thousands position. In the same way, the hundreds position can be taken care in 6 ways. And you can see that the tens position also can be taken care in 6 ways. But please be aware, if I am going to consider, I told you the 10,000s position, I can fill it either with a 2 or with a 3. In this, I cannot consider the 20,000 because I have told you excluding the extremes. Okay, so keep that in mind. So here you can see that the total number of ways I can take care of this, it will be 2 into 6 into 6 into 6 into 5. And you can see this will come here as 2160. You may think that 2160 is the answer, but let me tell you 2160 is not the answer because in this 2160, you are considering a possibility that is 20,000. Okay, 20,000 is one of these included in 2160, but 20,000 cannot be considered. Okay, so my answer will be 2160 minus 1 and that will be 2159. Got it? So for this question, option D, 2159, that is going to be my final choice. Because they have told you that it is excluding the extremes. Got it? Now, if they didn't mention this, listen carefully, I will go for one more possibility. If they didn't mention this, excluding the extremes, they have not told you. How many even numbers can be formed between 20,000 and 40,000? Using these digits, if they have told you, then you can see that my answer it will be this 2160. Anyway, it is there. Okay. Plus, what is going to happen? That 40,000, it starts with 4 when you consider. You can have only one case, that is 40,000. Okay. So that one will come. Then my answer would have been 2161. But in the question, as they have told you, it is excluding the extremes. You find the total number that is starting with 2, the total number that is starting with 3. Put together, you can say it is 2160. In that, starting with 2, you exclude the 20,000 because extremes are not possible. Okay, extreme numbers are not possible. So 20,000 you excluded. 2160 minus 1, it will come. Okay, that 20,000 you are excluding. My answer will come as 2159. And this is my final answer here. All right. So I believe this is a very good question because you are dealing with some constraints and all. So you have to be careful while you are attempting this question. So I think it is clear to you all. Okay. Now let us go ahead with the next question. Here we go. Have a look at this question. A boat is to be manned by 8 men, of whom one cannot row on the bow side and 2 cannot row on the stroke side. How many ways can the crew be arranged? I'm sure that you are aware that a boat has got 2 sides. Okay, maybe right and left we can say. So one cannot row on the bow side. What does that mean? It means that that guy will definitely go to the stroke side. So one guy, okay, he insists that he wants to be there in the stroke side. Okay, it is given that 2 cannot row on the stroke side. So I can thus infer that these 2 guys, they insist that they want to be part of the bow side. Got it? They want to be part of the bow side. Because you have got only 2 options, right? Because the boat is to be manned by 8 men, they have told you. So definitely, if you don't want to sit on the bow side, you have to go to the stroke side. If you don't want to be on the stroke side, then obviously you should go to the bow side. Okay. So if it's A bar, it has to be B. If it is B bar, it has to be A. That is the simple logic here. Okay. So now the question is altogether 2 plus 1, 3. Those 3 people, they have got preferences. So 8 people are there altogether. In that, 3, they have got some kind of a preference. The remaining 5, they are okay with anywhere they want. They want to be accommodated. So my question is, in how many ways this can actually be done? Okay, so please think about this. I shall explain it. So here we go. The explanation is as follows. I'm just considering that this is the boat here. Okay. Perspectives can be slightly different, but let me say that this is the bow side, and I will use a different color here for your understanding. This is the bow side, and please be aware that this is the stroke side. Okay. So you can see that 2 people, they want to be there in the stroke side. So I'm just fixing them here. Okay. And one guy, this guy need to be in the stroke side. Green color. Okay. So that's what it is. So you can see that altogether, there are 2 places to be taken care in the bow side, and 3, it need to be taken care in the stroke side. So listen carefully. 2 to be filled in the bow side and 3 to be filled in the stroke side. Altogether, 5 you need to take care. Now, please be aware the number of ways you can get this thing done. It is 5 factorial divided by, because you have to divide that 5 into 2 groups. Listen carefully, the remaining 5, they don't have any problem, right? So you have to divide them into 2 groups. One, the 2 people which are going to the bow side, and the remaining 3, they will be going to the other side. But there is no preference over there. So you have to divide 5 into 2 groups. Group number 1, 2, and group number 2, it is 3. The number of ways that you can do it, it will be 5 factorial upon 2 factorial into 3 factorial. I repeat, the number of ways you have to divide this 5 into 2 groups. Group 1, 2 people. Group 2, 3 people. The number of ways you can do it, it is 5 factorial divided by 2 factorial into 3 factorial. This is an important result in our permutations and combinations. The total 5, you have to divide it into 2 groups. I'm writing it here, group 1. Okay, they will be sitting on the bow side, and group 2, okay, they will be sitting on the stroke side. The number of ways you can do it, please be aware, it is 5 factorial by 2 factorial into 3 factorial. So that way you can split those people. So that is done. Now, I just talked about the way you are splitting the team. Now it is about arranging them. These 4 people in the bow side, they can be within themselves permuted in 4 factorial ways. And these 4 who are on the stroke side, 1, 2, 3, 4, 4 people you see, right? They can be arranged in 4 factorial ways. So the total number of ways that can happen, it will be taking care of these 5 people. That is 5 factorial by 2 factorial into 3 factorial. That allocation is over. Now, within themselves, it is 4 factorial. Within themselves, it's another 4 factorial. So the total number of ways, it will be 5 factorial by 2 factorial into 3 factorial into 4 factorial into 4 factorial. You can see this will give you the final count here as 5,760. You finish the calculation, you can say this will come as 5760. So that many number of ways the crew can be arranged. And the main take home from this particular question, it is that this 5, the total 5, suppose you are going to arrange them into 2 groups. 5, you want to split them into 2 groups. Group 1, it consists of 2 people. Group 2, it consists of 3 people. The total number of ways you can do it, it is 5 factorial by 2 factorial into 3 factorial. This is the big revision and learning that you are making here. So you take care of these 5 who don't have any particular preferences or condition. And then within themselves, the 4 factorial and 4 factorial comes into picture. The total number of ways will be 5760. That is my final answer. Okay, make a note of this. Let us now go to the next question. We have completed 8 questions so far. Let us now go to the next one. Take a look at this. In how many ways can 6 boys and 6 girls sit around a circular table so that no 2 boys sit next to each other? So please be aware, suppose you are having a round table arrangement. Okay. So the number of ways that these people, they can be arranged. Let us consider. One second. I'm considering a round table arrangement here. Let us consider that altogether if there are n people, okay? Altogether if there are n people, these n people, they can be arranged around a table in n minus 1 factorial. The number of ways you can arrange these n people around a table, it will be n minus 1 factorial. Okay, so keep that in mind. There are altogether 6 boys. So 1, 2, 3, 4. So altogether there are 6 persons, 6 girls. So it's a 12-seater, right? So 1, 2, 3, 4, 5, 6, 7, 8. You can think of 9, 10. And then you can think of 11, 12. Okay, so altogether 12 are there. It is given that no two boys, they sit next to each other, which means the arrangement under consideration, boy, 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 and boy. Okay. And you can consider that the remaining positions here, girl and a 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 girl. Like that only it is possible. Okay. So let us bother about the situation where, see, these 6 girls, they don't have any constraint, right? So we can consider that these 6 girls, let us arrange them first. Okay. So the 6 girls, they can be arranged first because they don't have any constraints as per. Okay. So these 6 girls, they can be arranged all together in 5 factorial ways, right? Let us focus only on arranging the girls. Let's not right now focus on arranging the boys. Okay. So that's the best way to do this question. Okay. So those 6 girls, 1, 2, 3, 4, 5, 6. See this? There are 6 seats available. Okay, I won't say 6 seats. I'm just saying those 6 girls, they can be arranged around a circular table all together in 5 factorial ways. Done. So you have finished arranging these 6 girls. Now we are going to consider allocating the boys. So the first boy or any boy you take, that boy should be placed in between 2 girls. So that first boy will sit in between 2 girls. You can see that the second boy will be sit in between 2 girls. The third boy in between 2 girls. Okay. The fourth boy in between 2 girls. The fifth boy in between 2 girls. And the final guy will be sitting here. Got it? So you can see that when it comes to arranging the boys, there are 6 seats, 1, 2, 3, 4, 5, 6, or 6 positions. So these 6 boys, you can see that they can be altogether arranged in 6 factorial ways. Okay. Because these 6 seats are available. It's no longer becoming a circular arrangement when it comes to the boys because they are having that constraint that no two boys, they are sitting next to each other. So you can see first you arrange the girls. That can be done in 5 factorial ways. Then you take care of the boys. So you can see once you arrange the girls, you will see that there are 6 positions here like this, and those 6 boys can be placed in those 6 positions altogether in 6 factorial ways. The arrangement is complete only when you take care of the 6 girls and 6 boys. So boys and girls, when it comes in terms of arrangement, the final answer, it will be 5 factorial into 6 factorial. I can say altogether 5 factorial into 6 factorial. Okay, they have given it. When I'm looking at the options, I can see that option C, it reads 5 factorial into 6 factorial. And for this question, the final answer, it will be option C, as you can see. Okay, so that's for this particular question. Okay, now let us go ahead with the next question. The 10th question in this lot. Have a look at this question. Sheetal invites 10 of her friends for lunch and seats 5 of them around a table and the remaining 5 around another round table. Find the number of ways in which she can seat all her 10 friends. So please note, This is in continuation with that board question, the row side, the stroke side we considered, right? So you can see that this 10, you have to form them into two groups. Group 1, 5, and you can say group 2, that is going to be another 5. Okay, so group 1 consists of 5 members, group 2 consists of 5 members. You are just segregating those 10 into two groups. The first 5, the second 5. So please be aware, these number of ways you can split this 10 into two groups. That can happen in 10 factorial divided by 5 factorial into 5 factorial. So you have now split them into two groups. All good? Fine. Now the next question is, the group is ready. Okay, so that first group is ready with 5 people. Those 5 people, you have to arrange them around a table. How many ways you can do that? That will happen in 4 factorial ways. N people, you can arrange them around a table in n factorial ways, right? Sorry, n minus 1 factorial ways, right? N people around a table is n minus 1 factorial. So 5, they can be arranged around a table in 4 factorial ways. Similarly, the second group, 5 are there. You have to place them around another table. So that can happen again in 4 factorial ways. So the total work that you are doing is, the first task is, you have to segregate them into two groups. Okay, that is task 1. That task 1, it can be completed in 10 factorial by 5 factorial into 5 factorial. That first task. Now you take care of the first group. You arrange those 5 people around the table. So that can be considered as task number 2. And the same way, the next group which is available, task number 3, you have to arrange that or those 5 people around the table. That is task number 3. Got it? So you got 3 tasks here. Task 1 can be done in some number of ways. Task 2 in another number of ways. Task 3 in another number of ways. The work is over only when you take care of segregating them into two groups and arranging them. Okay, individual groups. So segregating them into two groups, arranging the first group and arranging the second group. So the total number of ways will be like this. Please observe all these questions that we are discussing. It is centered around that fundamental principle of counting. Okay, so group task 1 and 2 and 3. So this many number of ways it is going to happen. And I can see that here the answer, it is option B, as you can see. Okay, so I will go ahead with option B as my choice. Okay, now let's go for one more question. I think time is still 10:45. So we will go ahead with one more question. Question number 11. As we said, it is Ega Dasham, right? So let's go ahead with 11 questions in today's discussion altogether. Okay, let me take the question here. It's again an application of what you just we have considered. Okay. Have a look at this question. We can see there is a double-decker bus which can accommodate 100 passengers, 60 in the lower deck and 40 in the upper deck. In how many ways can these 100 passengers be accommodated? If 50 of them, they want to be in the lower deck only, and 10 they want to be in the upper deck only. Okay. So have a look at that question. I shall explain it. So out of 100, I can see that upper, it is equal to 40. Lower, the seats available, it is equal to 60. Okay, 60 in the lower deck, 40 in the upper deck. Total number of seats, it is 100. Okay, so this is the seat allocation. Now, preferences, 100. Okay, upper and lower. What do they say? They can say that 15 of them, they want to be in the lower deck only. And the remaining 10 of them, they want to be in the upper deck only. right? So 15 plus 10, 25 people, they have a clarity. Where do they want to be there? They have a clarity. 15 plus 10, 25 of them. Which means the remaining, how much it is? You can see that the remaining, it is 75. Those 75, they are okay with either upper or either with lower. So 10 upper is already filled, right? So how many are available now? In the upper deck side, how many are available? Out of 40, 10 is already filled because those 10 people, they have got the preference. So now 30 is yet to be taken care. So that this 30 plus 10, 40 will happen here. So this 30 will come here. Okay. Now the remaining, when I consider 75, right? So 45, they will go towards the lower deck. These 30 plus 45, 75, they don't have any particular preference. So your task now, it is to split that remaining 75 who don't have any conditions. They are okay with upper or lower. Split that 75 into two groups. One group 30, another group it is 45. How many ways you can do it? That will happen 75 factorial divided by 30 factorial into 45 factorial. You got it? So that is the first task that is happening. Now let me read the question once again. In how many ways can these 100 passengers be accommodated? They are now talking about how many ways they can be arranged. It is about accommodating them. Okay, if 15 of them, they want to be in the low and then want to be in the upper deck. That's all they have asked you there. In how many ways the accommodation part can be done. Okay, they are not talking about arranging them, but rather how you can actually place them. That's all you need to take care here. So my answer will be 75 factorial upon 30 factorial into 45 factorial. It comes this way. I can go ahead with option B as my choice. Got it? Now, suppose if the question says seat numbers are there 1 to 40 in the upper and seat numbers are there 1 to 60 in the lower. So then it comes, okay, further, if some more constraints are there, then you can go ahead with this 40 factorial and 60 factorial here. In how many ways you can arrange them in the seat based on the seat numbers, how it can be done. If those constraints are added, then you can include them, you will get the answer. Got it. But here, since that is not given, it is just a matter of accommodating them either in the upper deck or in the lower deck only. That's all the question it asks. So there, you can just stop attempting the question here because you should know that also, where to start and where to stop, right? So here, the question demands only you allocating them or accommodating them in the upper or in the lower. Further arrangement, you are not focusing here. So my answer will be 75 factorial upon 30 factorial into 45 factorial. Option B will be my choice here. All right. So dear students, with this question, we are concluding the first phase of our discussion that is based on permutations and combinations. And stay tuned for more interesting lectures based on advanced questions from PNC and also questions based on applications of PNC. All right.